Hi everyone, welcome to our 7th video. In this episode, we are going to improve the driver control or operator control routine that we wrote in the last video. So in that code, there were some aspects of it that are not very nice. I mean, in the code itself. So for someone who's a more experienced programmer, they would look at the code that we wrote and say that it's really gross and that it could be made a lot cleaner if we change some things. And so we're going to talk about how we can change those things now in this episode. And the reason why we didn't write the code in the quote-unquote cleaner way in the first place is because I think it's more important to first just learn how to do things, and then you can learn how to do things better afterwards. So we started with the simplest, in my opinion, easiest to learn solution, and now we're going to make it better with a more advanced solution. And part of why the solution is more advanced is because we're going to have to learn about something new called if statements, and also something new called variables. And so basically I try to avoid introducing anything. I introduce as few things as possible in the beginning, and now in this video we're going to introduce two new programming concepts in order to improve the way that our code looks, basically. And it's important that we learn these because eventually they're going to become crucial, we're going to have to use them, and it'll be really onerous not to. And it almost already was. This solution where we add stuff together for the lift and the intake was kind of a pain in the butt to write. And it could have been easier, I think, if we had used if statements in the first place, but I didn't want to have to teach those right away. I wanted to try and make stuff work before we taught anything more. And now that we have stuff working, we can learn something new, and we're going to not really add a whole lot of functionality to the code. We're just going to do the same thing but in a different way. So I think it'll be a good exercise. So first off, I want to take our base control code here. I'm going to delete it because I want to bring back the tank drive code because I like tank drive better. And maybe I should have paid more attention to what I just deleted, but I think I can remember how it went. Not 5. Okay, so I think that's the code we had before. I think, oh wait, no, this needs to be reversed. I bet I made another mistake besides. But we'll find out. So I think this is the code we had before for our tank drive control. Let's put that back on the robot. And also, so another reason why we're doing this is because we need this functionality now. We need to know if statements in order to improve the way that our code works in some of the ways that I want to. Like I said in the last video that we want to make the lift stay up rather than falling back down. We need if statements to do that. Okay, and I did it. I was right actually for once on the first try. So the tank drive works the way it should now. If you want, here's proof. Wow, it's really laggy this time. Okay, so there's our tank drive working. And so now let's talk about the first thing that I want to fix. So you might notice, if you're actually doing this with me, that when you let go of the joystick, the motors are supposed to turn off and not be running at all, but they actually stay on just a little tiny bit, and they make this really annoying whining sound. And you probably can't hear it in the video, but let me put the microphone by the robot and then maybe you can. And so that sound is because the joysticks don't go back to the very center of their axis perfectly. They just go back close to it, and so the motor ends up, instead of getting 0, it gets set to like 1 or 2 or something small like that, and it causes them to whine and make that whining sound, is what I mean, because it's not enough to make them turn, it's not enough to move the robot, but it is enough for them to make noise. And it's kind of annoying, and basically everyone does something like this in order to eliminate that problem. So their solution, and let me show you pros again, their solution is to only set the motor to whatever the joystick is if the joystick is moved by a relatively large amount. And it's called a deadband. So if the joystick is only moved by a tiny bit, which would be this case when you're not touching it, so when it doesn't go back quite to 0, it instead goes back to like 1 or -2 or something, it's just moved a tiny bit, and so in that case, we set the motor to 0. And if the joystick is moved by a lot, so like let's say 10 or 20, 100, then we actually set the motor to the position of the joystick. So the way that we're going to add this to our code is using if statements. And the logic of how they work is really fairly simple, in fact. So we say if, and then we put, this is the harder part is the syntax, which means like how you type it, because you have to be somewhat exact, and it's a little bit different than writing the commands like we were before, so it can trip people up at first. So you write the word if, and then you put parentheses, and it automatically will create the closing parentheses for you, because you always need opening and closing parentheses or curly braces or whatever you're using in C. So parentheses, and then in here we put what's called the condition. So if blank, and then after that we're going to do something. So our condition is going to be if the joystick and we want if the position is greater than 10, oops, not 210, if it's greater than 10, then we're going to set the motor to the position of the joystick like we've been doing. And so we close out the parentheses at the end of the condition, and then we use a curly brace like we saw up here, and then we put what we do inside of the curly braces. So what we do is we set the motor to the position of the joystick, so I'm going to move that in here. So now what happens is if the joystick is moved to a position greater than 10, then we set the motors 3 and 4 to the position of the joystick. And if it's moved to a position of less than 10, then it will skip these 2 lines of code. It won't set the motors 3 and 4, and it'll go down to this and do motors 7 and 8, and etc., the rest of the code here. But it'll skip this stuff inside the if statement if the joystick is not greater than 10. So there's a couple problems with this, and I could put on the robot and show you, but I think it kind of wastes time and probably makes these videos a little boring. So I'm just going to tell you what would happen if we tried to use this code right now. So first off, if we move the joystick backwards, so if we move it all the way down, we would get -127, which is not greater than 10. So it would skip these lines of code and we wouldn't set our motors. But we want to set our motors because that's how we go backwards. So we need to fix that so that we can go forwards and backwards rather than only forwards. So we want the magnitude of the joystick to be greater than 10, or in other words, the absolute value. And so what we can do is we can say ABS and parentheses and then our joystick. And that means the absolute value of this number. And this number is the joystick position. So if the absolute value of joystick position is greater than 10, then we set the motors. So now negative 127 of a joystick position would become positive 127 when you take the absolute value, and positive 127 is greater than 0. So then it will go down here and set the motors, and notice we don't set the motors to the absolute value because then we would always go forward, but you just set them to what the joystick actually is. So we would set them to negative 127 here. Okay, and now the second problem with this here is that we don't have any way of now setting the motors back to 0. So if we are, it's like, let's say we're pushing the joystick all the way forward, so we have 127, we're setting the motors, the if statement is true, and then we let go of the joystick and it goes back to, you know, say like negative 1 or 1, whatever. So then this is no longer true, and then we don't set the motors, and not setting the motors doesn't mean that the motors stop. It means that they'll keep doing what we last set them to, which would be 127. So now the robot continues to drive forwards forever. And that's not what we want. What we want is to set the motors to 0. So what we do is we can add what's called an else statement now. And so now we have an if-else condition. If else means if this is not true. So if the absolute value of the joystick is greater than 10, then we set the motors like this. Or else, if the absolute value is not greater than 10, then what we're going to do is set the motors to 0. So now, when our joystick's position is like 1 or 5 or negative 7, we set the motors to 0, regardless of what it is, as long as it's not greater than 10. So before, we would still set the motors to 5, for example, and that would cause them to whine and make the annoying noise, but now we set them to 0. And the reason why we choose 10 is because we say like approximately any number greater than 10 is enough to make the robot move, and also when the joystick doesn't go back to the center perfectly, it's something less than 10, unless our joystick's really messed up. And our dogs are barking at something. I'm not sure if you can hear them. Okay, and so then we need to do the same thing with our other joystick and our other side of the drive. So we say if, and now we're going to use the other joystick. So axis 2. And we're going to need the absolute value of that once more. And then we also need the else in order to set these motors equal to 0. And by the way else works, well, the way both these work is so we have if, else, and then we have a new if, so it starts over. So this else doesn't apply to this if. So it's not like if this is not true, then else do this and else do this. No, instead, if this is not true, then else do this. If this one is not true, then else do this. And when I say true, I mean the absolute value of the joystick is greater than 10. That would be true. If the absolute value of the joystick is not greater than 10, then that would be false. Okay, and I need to change these. They should not be 3 and 4. They should be 7 and 8. And I don't notice any other mistakes, although there probably are some. So let's test this code and find out what they are. And so now what we should see happen after I upload this is that the tank drive code should work the same way that it did previously. And the only difference would be that we won't get the whining sound. And honestly, like, you won't even really notice that in the video unless I decide to hold the microphone up to it again. And I'm not even sure if you could hear it before. But now we have like code that looks vastly different. that does almost exactly the same thing as it did before. Okay, and let's go back to the camera. There. Okay, and so let's see. Looks good. Looks good. Okay, and so the code, or tank drive, still works just fine, just like it did before. But now there's no whining sound. And you can take my word for it, it's not whining. And if you try this with your own robot, I'm sure you'll notice a difference. Because the whining really is obnoxious. And so there, now we've learned about if statements a little bit here with our drive code. And now let's go ahead and apply them one more time to our lift code here. So what I want to instead have the lift the way I want to write the lift code instead is say if if the up button is pressed, so that's joystick digital blah blah blah. Oops. And when it's pressed, it is equal to 1. If it's not pressed, then it would be equal to then it would be equal to 0. So this means pressed. 1 is pressed. When it's pressed, we are going to set all of the lift motors to positive 127. So I want them to go up as fast as they can, which is basically what we had before. And I'm going to look at how I had them reversed down here, so that I make sure I reverse them all in the same way, and hopefully we don't have to go through that whole process again. Oops, motor 2. Okay, yes, that looks right. And so now I don't need this anymore. So now I've replaced that with code inside the if statement. And so if the up button is pressed, then we set the motors to go up. But how do we go down, for example? So now if the button's not pressed, then again we have this problem where we're not setting the motors at all, and they'll keep doing the last thing we told them to do, which would be to go up. So we need to make a way for it to be stopped. So we're going to once more add else. And notice there's no condition for else. So it's if this is true, if the button is pressed, and if not, then you do else. So any other circumstance, regardless of what it is, you do the else. And what we want this to be, and let me copy and paste to save time, is to set them to 0. So turn the motors off. Make them stop turning. 0, 0. Okay, and so now we can go up. When we hold down the button, and when we let go of the button, the motors will stop. But we also need to be able to go down. And before we accomplish that by adding the buttons together, and now we have a, in my opinion, better solution. Using our if-else logic, now we can use what is called else if, and so this allows us to have another condition. So we can do the button up is pressed, we do this, or if it's not pressed, and if the down button is pressed, then we can do something else. So let me get the down button here. So equals to 1 means it's pressed. So if down button is pressed, then we're going to have the motors all go the opposite direction, which would be down. And let me walk through this logic one more time. So if the up button is pressed, then we set the motors to go up in the up direction. Or if it's not pressed and the down button is pressed, then we tell the motors to go down. And if that's not true either, so if this is not pressed and this is not pressed, then we tell the motors to turn off. We turn the motors off. So we have 3 different options: go up, go down, or off. And if, just to like clarify some things, if instead we had like made this be just another if, then we would have a slightly different circumstance. So then if this is true, we would tell the motors to go up, and if it wasn't true, then we just skip it. And if this is true, we would tell the motors to go down, and if it weren't true, we would tell the motors to turn off. So for example, if we were pressing the up button but not the down button, it would do both this and this, which would be bad, because now we have the situation where we have 2 different motor set commands for the same motor fighting each other. Because on one hand we're pressing up, but we are not pressing down, so it does the else, which is turn them off. So now we're trying to go up and off at the same time, and that's not what we want. So it needs to be else if, so that way this else is in like the same like series. You can think of it as this if command. So this is all one block of if, else, and if we made this if, then this will be its own thing, and then these 2 are associated with each other, which is not what we want. So basically, if you have a series of these things that are all associated with the same subsystem, you probably want to use if, else, or if, else, if. You can have as many else if as you want, and then else. Okie doke. So let's test this code and see what we get happening here. And so once again, this should do the exact same thing as what we had written before, but now we've written the code in a way that looks vastly different, even though it has the same functionality. Okay, so show this guy to you. Okay, and so now when I press the lift up button, it should go up, and when I press the down one, it goes down, up, down, and when I let go, the motors are turned off. Okay, and so that works just with the way we expect, just the way it did before. Now let me talk about how I mentioned we could make the lift stay up on its own. So instead, the solution is going to be that instead of turning the motors off when we aren't pressing the buttons, we're instead going to set the motors to a small value that'll be just enough to keep it from falling down, to basically hold the lift up but not move the lift. And so a value of 10 is usually a pretty safe thing to go with. If you go, I think, like larger than 15 about, then you run into the risk of overheating your motors if you do it for an extended period of time. Less than 15, you can do it pretty much indefinitely without overheating your motors. So we're going to just use 10. And so now this will give the motors a small power in the opposite direction of falling down, and it should hold the lift up. Yeah. And so it'll always be giving them the small power when we aren't pressing any buttons. And so now we will have the problem of the lift motors making the whining noise, but it's at least serving a purpose in this case. Upload that. And I don't know if you can hear it, but they're now whining. And so now let's see how this works. As soon as it connects. Okay, so now if I raise the lift up a little bit, it'll stay up. And that makes it a lot easier to drive the robot if I, for example, need to like hold the lift up and then drive up to some kind of goal or something. But one problem that you'll notice is if I try and put the lift all the way down, it has a tendency to want to spring back up at least a little bit because it always has that motor power pushing it up. And you'll notice also if I just gently, super gently push on this, it wants to come up with my hand. Whereas if I like turn off my joystick, now it wants to fall back down. So the advantage here is now we can hold the lift up, but we can't keep it down all the way. So one solution to that would be that we could use some kind of sensor to determine where the lift is at and only tell it to hold the lift up if the lift is sufficiently high. Or another solution that we will look at in the future is to only have the lift stay up if the last button we pressed was to tell it to go up. But that's where we're going to stop for this video because we now introduced our if-else logic. And in the next video, we're going to introduce variables.